With liftoff from a tropical rainforest to the edge of time itself, James Webb begins a voyage back to the birth of the universe.
When you stare at the sky on a moonless night, you can see thousands of stars, all with light years of darkness in between them. Beyond twinkling stars, the universe is an extraordinarily dark and mysterious place. Not even 5% of the universe's mass is actually visible to us. What makes up the rest of it? For years, astrophysicists have sought to explain this invisible material that fills the universe. How do scientists study something they can't see? And what do they hope to gain by solving the mystery? You're watching Matter, and here's how the James Webb Telescope could solve the mystery of dark matter. When NASA launched the Hubble Space Telescope in 1990, no one knew what Hubble would be able to find out in our cosmos. The images and information it collected drastically changed the field of astronomy and helped scientists form a better understanding of our cosmos.
The Hubble observes at ultraviolet wavelengths, visible wavelengths, and just a little bit of the infrared. And the Webb telescope starts with red wavelengths and goes all the way out to 28 microns, which is much longer, and shows us new things.
It's now time for the next evolution of telescopes to have a chance to collect more information than ever before, and there is no telling what it will find. NASA just launched the latest telescope that is going to look deep into our universe.
It's 100 times more powerful than Hubble and able to see into these cocoons, these sort of, pillars of creation as they're called, where planets are actually coalescing and we're seeing the beginnings of what we have now in this solar system.
The James Webb Telescope is now in orbit and will begin operations within the year. Scientists are hoping that the James Webb Telescope will help them answer some questions that have been plaguing science for some time now. One of the questions that they are hoping to get closer to an answer for is the mystery of dark matter. Scientists know that it's very prevalent within the universe, but they do not know what it is made of and where it came from. But what even is dark matter? In 1933, a Swiss-American astronomer by the name of Fritz Zwicky was studying the Coma cluster of galaxies and calculated that the mass of all of the stars within the cluster did not generate nearly enough gravity to hold the entire structure together. The mass could have only produced 1% of the total gravity needed to hold the cluster together. This was the first real piece of evidence that dark matter existed. Dark matter is the name that astronomers gave to this mysterious invisible mass that is responsible for holding some of the largest structures in the universe together. This weird, invisible mass makes up 27% of the universe's total mass, while ordinary matter that makes up everything we can see only accounts for less than 5% of the universe's mass. Since the first evidence appeared, there have been many theories trying to work out what dark matter is made of, but none of them have been able to fully explain what is beyond a reasonable doubt. Currently, the top contender for what dark matter is are theoretical particles called weakly interacting massive particles, or WIMPs, that are very heavy and extremely slow-moving. These particles have been considered as a possible source of the gravitational forces that scientists attribute to dark matter. But more recent experimental data that has come out recently is starting to have some physicists worry that the WIMPs theory may not hold up as well as they originally wanted. The hope among scientists is that the Dark Webb Telescope is able to shed some more light onto dark matter, or at least point scientists in the right direction to finally answer the dark matter question that has eluded them since 1993. One of the theories that is going to be put to the test when the James Webb Telescope is in operation was originally put forth by Stephen Hawking. In the early 1970s, Hawking turned his focus towards black holes and the birth of our universe. He postulated that in the first few moments of the universe's existence after the Big Bang, there were areas of the early universe that had greater density than its surroundings. These dense areas could have led to the formation of the very first black holes. The first few moments of the universe was extremely hot. So hot that black holes could not form yet. So it was not until the universe spread out further and cooled off enough for the particles to begin to coalesce together. The first black holes, also called primordial black holes, from the dawn of time could be the dark matter that helped form the universe we see today. Hawking's theory did not gain a lot of popularity and moved out of the current views of dark matter. But, as the new experimental data has come out in recent years, more physicists begin to revisit different theories about dark matter and test them again with this new data. The primordial black hole theory seemed to be more plausible than previously believed, using computer simulations to model a universe that creates primordial black holes soon after the Big Bang. They found that black holes forming this early did lead to a universe that looks similar to ours 14 billion years later. But this model also showed stars forming in the early universe as early as 50 million years after the Big Bang. This would mean that stars began forming long before the 300 million years after the Big Bang the current model of the universe predicts. Scientists who are working towards strengthening these theories are hoping that a new trove of information will come out of the James Webb Telescope that'll help them come closer to finding out what the dark matter is. If this new model of the universe is correct, and primordial black holes began to form shortly after the Big Bang, leading to stars forming 50 million years later, scientists are counting on James Webb to give them the clues to help them know for sure. The James Webb Telescope was designed to look deeper into the universe than anything science has made before. It was built to detect and collect signals from 13.5 billion years ago, just 500 million years after the Big Bang. It would look further back through the deep field where Hubble found some of the oldest galaxies we know of to try and detect more ancient stars from the very early universe. If stars were forming 50 million years after the Big Bang, astronomers expect that the James Webb Telescope will be able to see a number of stars when it looks as far back as it can. Only when the James Webb Telescope is fully deployed and collects enough data to produce an accurate picture of the universe at this time will scientists get their answer. If James Webb does see early star formations forming when it looks back a few hundred million years after the Big Bang, there is good reason to believe that the primordial black holes were formed in the early life of the universe. This would be a fantastic breakthrough, helping to strengthen Hawking's theory about dark matter being ancient black holes. It will also help scientists build a better understanding of the formation of our universe by getting a more accurate picture of its earlier times. Using current technology, scientists have only been able to explore the universe up to 13 billion years ago. Much of their understanding of the universe at an earlier time than that still has many unknowns. And hopefully, with the launch of this new telescope, many questions will finally be answered. If James Webb does not detect any star formations when it stares back into the early universe, it would signal to scientists that the correct model of our universe may not be going down the correct path. Theories in science are always held to a very high degree, and if one gets disproven, there is always another scientist to prove a new way of looking at different problems. Astronomers will still be able to use the capabilities of the James Webb Telescope to learn much about the universe. They will be able to study the effects that dark matter has on the matter that we can see within the universe, and they will be able to take a closer look at the galactic clusters and other large-scale cosmic structures that rely on dark matter to form. This alone may help physicists finally find some answers about dark matter and may shed light on what it actually is. Whether or not the James Webb Telescope detects stars when looking deep into the universe's past, its launch marks another step in discovering what lies out in our universe and a step closer to understanding the workings of the cosmos. Did you watch NASA launching the James Webb Telescope into space? What do you hope it finds lurking out in the depths of space? Be sure to join us next time, and if you watched all the way to the end, we want to say thank you. And if you enjoyed this video, please feel free to hit the like and subscribe button so you won't miss out on any of our future videos.